Hey guys, this is Kanav, and this is going to be the fourth video in my 3D modeling YouTube series using Autodesk Fusion 360. In this video, we are going to be talking about more sketch tools and the Revolute feature. Alright, so let's get into it. So right here, I have Fusion 360 open, and the first thing I'm going to do is I'm just going to create a sketch and the top plane. If you're following along, you can do it at any plane you want. I'm just going to use the top plane. And what we're going to learn, or I'm going to teach you in this video, is I'm going to be talking about arcs and ellipses. And I'm also going to be teaching you how to do fillets and chamfers. And in the constraints, I'm going to be teaching you how to do the tangent, equal, parallel, which I already briefly talked about in my third video with the phone mount, and the perpendicular constraint. And after that, I'm going to be teaching you guys construction. Alright, so let's go and talk about arcs. So arcs are basically just curved lines that you can use to make more complicated designs. So right here, the three main we're going to talk about are the 3-point arc, the center point arc, and the tangent arc. The 3-point arc is where you define two endpoints, or a start point and an end point, and then a middle point that will define the shape. The center point arc is where you already know the center of it, so you would put the center. The first point is the center of it. You can think of this one as like a fraction of a circle. So the first point is the center. The second one is where you define like the outside of the circle, and the third one is where you define like the angle of which the circle will kind of cover. So you can do like half a circle, maybe like a quarter of a circle, or maybe like, I don't know, 10/16 of a circle. And the tangent arc is where you have a line, and you would make this specific arc tangent to that line. And to give a brief description of what a tangent is, it means the flat side of a line will only touch the circle at one point. This is very helpful in just overall designing when it comes to parts. And if you want to like manufacture it with like a custom like manufacturing company, it would be very helpful to learn about just tangent arcs and just tangents in general. So let's start off with the 3-point arc. The 3-point arc, as I said earlier, is where you define a start point, an end point, and the middle point, which will define the shape. So the first point here, I'm going to define as the start point. I'm just going to click my left mouse button. And the second point, you can define anywhere, like the first point. I'll just define it here, making it easier, so I'll make it 50 millimeters. And I'll make sure you click. And the third point, as you can see, I can move it again anywhere I want, but the shape, as you can see, changes. So I'll put it here. And that is our first arc, or 3-point arc created. So this point right here, you can imagine this as the center point of a circle. So if I put a circle here and extend it out here, the contour of the 3-point arc will follow along with the circle, because arcs are basically just circles except fractions of it. So with that, what we're going to do in order to make this constraint is we can just define the points from each other and the points of the center of this, and with the other endpoints. So from here to here, I'm just going to make it 50 millimeters. And for the center point, I'm just going to make the height. You can make it anything you want, but I'll just make it 5 millimeters. And for the distance in the middle, I'm just make it 25 millimeters. And now we have our arc that is constrained. Now the center point arc is different, in that the first point you define is the center point, the second one you define is the outer point, and the third one you define is basically the angle. So to show that, the first point I'm going to again put the origin. The second point I'm just going to arbitrarily put it 50 millimeters away from the center and click here. And the third point, as you can see, you can define the angle as shown here. I'll make it 150 degrees. And voila, that is how you make a center point arc. Now these are very helpful if you already know the center of the of like a hole, and you can also already know the center point of where the arc is going to be. as compared to 3-point arc. Now the final arc I'm going to be talking about is going to be the tangential arc. So the tangential arc, or a tangent, if you don't know, is when a specific curve will only touch a line at one point, or the flat side of the line would just touch the circle at only one point. Now to give a visual representation, in order to show what a tangent arc is, I'll click on tangent arc. I'll click this point, and as you can see, the flat part of the line is only going to touch the circle at that one point. And in math, this is called a tangent. And it's only going to be tangent to this line right here. And the second point you can define anywhere you want. I'll just define it here. And as you can see, we made a new shape like that. So now we're going to be talking about ellipses. Ellipses are basically just ovals. And the way you would create it is you would first create a center point. And then what you would do is you would create the first dimension, which is going to be the length or the width of it. So you can create this as 80 millimeters or any length you want. It can be any angle you want. And then click it. And now what you will notice is it will have a line that's going to span perpendicular to it. And you can make this any dimension you want. Now this is different from circles, as you can see, because it has two different measurements for the diameters. The smaller diameter is going to be called the minor axis, and the larger one is called the major axis. So in this case, I'm going to make this the minor axis just because it's easier for me. And I'm going to make it 50 millimeters. I'm going to click on it, and we now have our little ellipses. And I'm going to just fix the point to make it constrained. Now that we've finished with our shapes, we're now going to go into modifying. Fillets, as I mentioned in the second video, are a way for you to round off an edge. This is going to be very helpful if you want to literally build the parts using like a 3D printer or a CNC, because it would make it more manufacturable and also easier. Well, yeah, more manufacturable. So the way you'd create a fillet is you can either select two sides, or you can just select a corner. I'll select the corner right here, and you can make a measurement. I'll make it 5. You can make it anything. 5. You can make it 10. You can even make it 20. 20. I'll make it 10 to make it easier. And when you press enter, it's going to have a message, or many times going to message that says constraints or dimensions are removed during operation. So one thing to note when doing fillets and chamfers is that, again, as I said, constraints can be removed. So you're going to have to most likely redefine them once you put the fillets. And with filleting, I would highly recommend you to actually do it outside of the sketch once you have bodies, because then constraints won't get removed and shapes won't get shifted once constraints get removed. So now let's talk about chamfers. Chamfers are similar to fillets, where they're going to make things more easily manufacturable, but it makes a flatter edge instead of a circle. So you do the same process where you can select two edges and a point. Now in this case, I'll select two edges, and we're again going to make it so that it's going to have a specific measurement. We'll make it 5 millimeters. Now, if you want to understand what these dimensions mean, the R means radius of a circle that's defined here, and is tangent to these two edges, like here. So 20 millimeters is the diameter, so that would mean that 10 millimeters is the radius. And for chamfers, you can kind of already see it, but this would just tell the measurement of the point here and the corner edge. Now that we've finished the fillets and chamfers, let's now move on to constraints. So the first constraint is going to be very helpful. It's a tangent constraint. As I stated earlier in the video, it's where you make the flat side of a line touch the circle at exactly one point. Now this is again super helpful when it comes to making manufacturable parts, and also super helpful when you want to make kind of complicated designs. So in order to show what this constraint does, we're going to first define a line that's going to be right here. It's going to be, I'm going to zoom out. sorry, it's going to be about 50 millimeters. And the second thing, I'm going to find a circle. That's going to be right here. And it's also 50 millimeters. And it's going to be right here. Now, but the tangent constraint, what you have to do is you're going to have to select a line and a curve. It can be a circle or an arc or a spline. So once you select both of them, as you can see, the circle is now constrained to line, so they can only touch it once. Now let's move on to the equal constraint. The equal constraint is very helpful when it comes to making multiple holes. So I'm gonna make a couple other circles. I'm gonna make this, doesn't matter the measurement. I'll make it like here, 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 and here. And what the equal constraint does is it makes the size of these circles the same. So I'll just select here and here, here and here, and here and here. So these are all related to one dimension, 50 millimeters. Now what's super helpful is that if you change this to like 20, all of the circles or anything is going to change respective. Like if you have two lines that are both 110 millimeters, and if you change, and they have the equal constraint, if you change the dimension to 110, it will apply to both lines at the same time. And the same situation with the circles that are shown here. Now, the third one we're going to talk about is the parallel constraint. I already briefly mentioned this in my phone on CAD, but if you haven't seen that or forgotten, it's basically where you make two lines parallel, meaning that they're going to be straight next to each other and they can never touch if they infinitely extend their length. So the way we'll do this is we'll select one line and it'll select the other. And in this case, it will always go to either the constraint line or the one you would select. In this case, it would go to the constrained line. I would recommend when it comes to the parallel constraint to do it to constrain a line and then use it. Because it would make things a lot easier in the future. Now the final constraint is going to be called the perpendicular constraint, which is where we can have two lines or two objects at a 90-degree angle. So right here, I'm just going to make a random angle. And the perpendicular constraint, I will just select two lines that touch each other. Oh, sorry. I clicked the wrong one. Perpendicular constraint. And now it's at a 90-degree angle. This is very helpful if you want to make things like windows, doors, basically anything that's a 90-degree angle in that case. Now that we have finished with the constraints, let's talk about a very helpful tool that's called construction. Construction is where you would take a line or specific surface, or basically anything in sketches, and you would make it into a reference. Now to give a visual representation, I'll just make a line. I'll make the center point here, just to give it a representation. And once I select the line and I select construction, the line will now turn to a dotted line. Now this is very helpful where, let's just say when you want to extrude like a surface and you have to select like 50 different shapes or 50 different shaded areas, construction can make you do it so that you would have to select less areas. Now to give an example, let's say you're drawing a random shape where you're doing here and here and here and here, and you want to make this the one thing. You would select this and you would turn it into a construction. So now this is going to be one surface, but the best thing is that this line could still be selected in a sketch and it can be used so that you can like add a circle at this random point, and you can do a lot of other things with that. So this is and the best thing is that you don't remove any dimensions or constraints by this method as opposed to trimming. So that covers it for the construction tool. Now let's move on to the Revolute tool. So as you can see here, I created a random shape just to demonstrate on how Revolutes work. Now you can do any shape you want as long as you would have a line and follow the same steps as I do. So we can finish the sketch right now. And now let's start the Revolutes. So Revolutes are where you would take a profile. It can be anything you want. And what you can do is it will spin or rotate around the axis. You can make it go a full rotation. You can make it go partial. You can just even make it go to specific points. So in order to do Revolute, you would click the Revolute tool right here. And you can click a profile. I'll click 2 profiles because it's make it easier. And the axis. Now the axis you can select the basic origin axis, which is the X, Y, and Z axes. And the second thing that you could do is you can select a line. So I'm going to select a line right here. And as you can see, the object, this profile pic, is now rotated fully around this specific part. Now this is a very helpful tool that you can use to make like bearings, so, screwdrivers. You can make a tent that kind of looks like a tent right here. Just a lot of cool things that you can do with this. Now there are going to be the same features as extrude, where you can join a specific part, you can cut, you can intersect, or make a new body or a new component. Now in Revolutes, what you can actually do is you can specify a specific angle. Now 360 is a full rotation, but you can select, maybe half a rotation and only go halfway. I'll show it right here. It'll be a half rotation. And you can also even do, wacky angles, like maybe 36.5, and it'll just do that. Now, if you just want to go a full rotation, you won't have that constraint. Now that's going to be it for this video. In the next video, we're going to be going into patterns in sketches and outside of sketches. Alright, see ya.